Welcome back to Algebra 1. I want to take a look at the area method again because we're going to use it to find some patterns. And when we use the area method, we make sure that we split and each term of the polynomial goes in its separate part with the sign going with the term that it is connected to. Once we do that, we are going to complete the multiplication table. Negative times negative is positive. And then what we notice is these are the two that tend to be combined. So we end up with x squared. These are added now, so negative 4x plus 4. And we can have more complicated terms. But when we multiply those out in the times tables, we end up with 16x squared, negative 24, single x, negative 40x, and negative times negative is positive. Again, it's these two terms that combine. The other terms are all separate, and we like to write these in standard form. So the x squared goes first, then the x term, and finishing it off with the constant. So we're going to use that area method for a couple of patterns. And right now, A and B can stand for a number, a variable, a term that has both a number and a variable. We're going to see what happens when we split this up. We're going to start out by using the area method, and then we're going to come up with a pattern. When we multiply two variables, we tend to put them in alphabetical order. That way, instead of this one being BA and not recognizing it, when we put them in alphabetical order, we recognize that these two have the same terms in them. And although we don't tend to write it up here, and I'm just going to pick A to be the one that I'm going to put in standard form. Both of these guys have a 1 on them, so when I add those, it becomes 2AB and B squared. This is the pattern that we're going to use, A squared plus 2AB plus B squared. Whatever A and B are, they can be complex. We put them in parentheses. We can follow this pattern, or we can do the area method. This is our second pattern, and in this pattern here, we're going to have a negative sign on the B. And then once we follow the multiplication table, A squared, the negative is going to go in front, alphabetical order, AB. Again, the negative goes in front, alphabetical order. And negative times negative is positive. So again, we come up with a pattern. Our pattern is A squared. This time it's minus 2 times A times B. And B will end up being positive. There's only one place that I ended up having a negative sign, and that is right there. The pattern was identical to the last pattern, except for that negative sign. So if we follow the area method on this, and we have kind of a complex term here, we have 3. So in this particular case, we have a term that has 2 different parts to it, the 3 and the x. And we have to make sure that we multiply both of these out. There are 4 multiplications. It's a real common mistake to think we can distribute this, and we can't. When we multiply these out, 3 times 3 is 9. X times x is x squared. 3 times 4 I can do. 4 times 3 I can do. And 4 squared is 16. So these are the two that combine. These two are separate. In order to write it in standard form, we're going to start with the x squared term And this ends up being, well, 12 plus 12 is 24. We can also get that by saying 2 times 12. So that's if we stick with the area method. Now we do have another pattern. And in this particular pattern, I do have something different. I have 1 plus and 1 minus. It does not matter what side you put each variable term. But then we're going to multiply out the squares. A times a is a squared. In alphabetical order. This one becomes a b in alphabetical order. Now these two are still going to go together, but something rather unique happens. Remembering that both of these have a 1 on them. 1ab minus ab cancels. I am left with a negative sign in between two perfect squares, which is why this is called the difference of